Hi, this is Kent McVay at Southern Ag Research Center, and I'm standing in front of a study that's it's a nitrogen study on barley with Jamie Sherman, our barley breeder. She's been evaluating some different varieties for a low protein gene. So that's what this is all about.
So the study is evaluating malting barley nitrogen response. So the history of this project is that Tom Blake, the previous barley breeder, probably 10 years ago, crossed Hocket, a pretty popular variety for malt barley in Montana at the time, with Carl. When Carl had a low protein gene, so it kept protein low with higher nitrogen rates. And then he got busy, and that cross kind of sat on the shelf, and he didn't really develop anything with it. And then he retired. Jamie Sherman comes along, and she's a new barley breeder, about 5 years in the job. She sees this technology on the line and thinks it's a good idea. So she started developing lines from that. And then to prove that the low protein response is really true, she needed a test to do that. And so we had been doing nitrogen studies here at Southern Ag Research Center on barley for Miller Coors. And so I said, yeah, we can probably add that in. And so we did, and it does show that this genetics does keep the protein low even at higher nitrogen rates. Last year she had her first release from that cross called Buzz, and so you can, I think starting next year that will be available. And now this study is we're screening additional lines for release from that initial cross of Hocket and Carl. So my approach for looking at nitrogen response studies is this. We just use a plot drill, the same as we do for variety trials, and we plant a strip of plots, and their dimensions are around 5 feet wide, about 15 feet long. You can kind of see the dark green area that shows differences in plot length. But when I fertilize, we add 2 borders on either side of the series of treatments that we have, and then we fertilize between across the plot and half of each border. And so by doing that, we don't get nearly as much noise of edge effect that you would have if you were trying to fertilize, let's say, a really high nitrogen rate right next to a really low nitrogen rate, which lets you see here where a really light green color is next to a dark green color. Because nitrate moves with water, roots can move laterally in the soil and pick up nitrate from an adjacent plot, and so this really isolates those and does a pretty good job of cleaning up the data. So this is data from 2015 for Miller Coors, 5 Moravian varieties. They each have kind of different yield potentials. Fertilizer nitrogen along the x-axis, grain yield on the y-axis. But the response is very similar. And so you can take any one of those and fit it to a regression curve, and you can determine the maximum yield by just looking when the slope goes to 0. In all practicality, it makes more sense to compare it at 95% of that maximum yield, because this last few bushels takes a lot of nitrogen to get there. So most researchers and probably most producers, you wouldn't shoot for the maximum. You're going to shoot for something just under that maximum, which makes a little more economic sense. If you do that optimum nitrogen level, this is across several years for the Bill Coors 100 variety from 2014, it was 1.14 pounds of nitrogen per bushel. In 2015 and 16, it was more like 1.3. And then 2017, it dropped back down to 1.01 and 1.04, depending on location. If you average those, we end up with 1.16, which is right back to where we started, because the MSU recommendation for malt barley is 1.2. So there are differences over time, but it's probably yearly differences. It's kind of hard to get any more precise than that. This study that we're going to look at today is a randomized complete block with 4 replications There's 5 varieties and 4 nitrogen rates. That means there's 20 plots per rep. The nitrogen rate, we have really high residual nitrate this year because of a hailstorm we had last year. So the 0 nitrogen treatment ends up being 89 pounds coming from the soil. The 1X rate for a yield goal of 140 is 168 pounds. And then 1.5 times that's 252, and 2 times that is 336. That became our treatments for this year. Typically we have a 0.5, 1 and 1.5, but we can't get to 0.5 because of the high residual soil nitrate. So now we'll go back to the field.
So this is Buzz at the no nitrogen rate, the 0 nitrogen rate. This is Buzz at the full nitrogen rate that we recommend for 140 bushel yield goal. So a little bit greener than the 0 or the check one. Now this is Buzz at the 1.5 times nitrogen rate. So our 3rd rate of nitrogen. So a little bit darker green still than the previous ones. Now this is Buzz at the 2 times nitrogen rate. So that's still quite green and way different from what we have for the check, for sure. So we can't say definitely that just because it's greener longer that's going to give us better yield, although the data kind of shows that we do see a response to nitrogen, and I think that's what we'll see in the end. Hopefully, I didn't want to show you all the different varieties, just wanted to show you the response and how this works. Hopefully this will help Jamie's program. She does quite a bit of other testing with malt quality lab, so not only do we look at yield from this data set here, we also take these samples to Bozeman for a malting test so that they can find a product that the malt houses are also happy with. So thank you very much, and that's all I got. We'll see you next time.